In a previous video, we saw how we can search and process text. In this video, we will discuss how to take this a step further and manipulate the text itself. I do have one quick disclaimer before we begin though. Two of the utilities we are going to discuss, sed and awk, are very powerful and very complex. Entire books have been written on their usage. In fact, there is a sed script that implements the game Tetris. Unfortunately, this is a relatively short video, and we don't have time to fully discuss one of them, much less both of them. Rather, this video is intended to be a short introduction so you can learn more on your own. With that out of the way, let's look at the sed utility. Sed is short for stream editor. This means that it manipulates text as it flows by. Think of a car manufacturing assembly line. A worker may attach a car door to the frame as it passes by and then moves on to the next car frame. In the same way, sed manipulates text line by line as it is sent to it, unlike a normal text editor that operates on a file all at once. Let's look at a few examples using our file sample.txt. This file contains some fake name and address information. First, let's replace all of the full words suite with its abbreviation STE. The term sed uses for replacing text is substitution. We tell sed to substitute using the S command at the start of the expression, like this: sed S suite, the abbreviation, and our file. As you can see from the output, the word suite was replaced with its abbreviation. If the word had occurred more than once on a line, sed would have only replaced the first instance. Let me show you with an example using pipes. This is the same sed command, it's just getting input from the echo command that is piped through. Only the first instance of the word was replaced. If we want to replace every instance, we need to tell sed to do a global substitution by adding G at the end of the substitution expression. Now, every instance of suite on the line has been replaced with the abbreviation. If we want to restrict the substitution to a very specific occurrence and not every line, we can do that too. For example, let's say we only want to replace the last occurrence, this one. To do that, we add a dollar sign before the S indicating substitution. Notice only the last one was substituted. The dollar sign is shorthand for the last match found in the stream. We can also use other criteria to determine when sed should modify text. For example, let's write a command that instead of simply using the abbreviation of suite, deleted the entire line if the word suite was present. We still want to use the pattern suite to match lines, but we want to take a different action. The command to do this is suite D. Putting suite in between the slashes tells sed we want to match using the word suite as a pattern. The D after that tells sed to just delete the line if it matches the pattern. Notice that lines with sweet do not appear in the output. We can also use the matching criteria with the substitution command we have been using. For example, say we want to substitute the abbreviation of sweet for the word, but only when the line contains two E's next to one another. If we look at the lines that contain the word sweet, the line with Port Marlyfort and Marlene are the only ones with double E's. If we create the said command properly, those two lines will be the only ones in which the abbreviation is used. This is our command. Said. We use matching criteria but not substitution. Then a command for substitution. The first part of the command tells said to search for lines with double E's, and the second part tells said to do substitution. As you can see, the abbreviation was substituted on only the lines we wanted. In all of our examples so far, we have only used a single expression in our said commands. Sometimes, however, we may need to edit text in more than one way at a time. Consider, for example, the situation where we want to replace all the commas with a new line character. However, since it would be difficult to see where one record ends and the next begins, we would like to add a new line between each line before we split up the records. First, let's do this using two different sed commands using a pipe. First, we replace the end of each line, denoted by a $sign, with a new line character. We will then pipe the output of that sed command to a new sed command that replaces every comma with a new line. This command added a new line at the end, and we pipe it to one that replaces the commas with a new line. We can also do this with a single sed command that uses more than one expression. However, we need to tell sed that they are both expressions. We do that using the -e option. If we only have one expression, like all of the ones so far, sed is able to figure it out on its own without that -e option. Our new command will look like this. The first command for making it adding a new line at the end of every line, and then the other command for replacing commas with new lines. We can see the output is exactly the same. The second version is nice because we were able to accomplish it with a single command. But the first version is appealing in that the simplicity of using the pipe means that it could be easier to develop and debug two separate sed commands. Remember, there is much more that you can do with sed, but these examples should give you a good idea of what it can do and how to use it to solve your particular needs. Like sed, awk makes use of a simple programming language. However, unlike sed, which processes text as a stream, awk breaks each line of input into separate fields or columns using specific delimiters. The default delimiter is a space. Let's run a quick example to see it in action. Notice that awk separated the text into the fields delimited by spaces. We told awk to print the second field, which was Bob. We can use more than one field in an awk program. Each field is numbered starting at 1. If we wanted to print field 3, then 1, we would use the following command. Let's go back to the file we used for sed, sample.txt, so we can see how awk works with multi-line content. Let's say we want to extract the first field, which is the person's name. One challenge is that the file uses commas to separate the different fields, not spaces. We need to tell awk that we want to use commas to delimit fields and not the default spaces. We can do it with the -f option like this. Awk -f, we specify the comma as the delimiter. As you can see, we now have the names of the people. If we needed to format this a different way, say last name and then first name, we have a few options. To reinforce the usage of pipes from the previous video, let's see how we could use pipes to accomplish this reordering. The previous command displayed the name. In our example, the names are simple and don't involve any middle names or last names with more than one word. The first and last name are simply separated by a space. Since awk uses space as its default delimiter, we can simply send the output of the previous command to awk again using a pipe like this. Print the last name, a comma, and the first name. We want a space, we can put a space in the quotes. The first part of the command uses awk to print the name, which is the first field in the file. It then sends the output to another awk command using a pipe, which splits the name into a last name and a first name. We swap the order when we display it and insert the comma in a space. Awk can also filter lines based on a pattern. Let's say we only want to print the names of people that live in North or South Dakota. We can build on the first awk command we used. To filter based on the word Dakota, we simply put Dakota surrounded by slashes. Tell awk to use the comma delimiter. Notice that only the names of the two people that have the word Dakota in their record are printed. Now let's consider the case where I needed to know which line in the file corresponded to these names. awk has a number of built-in variables we can use to help with this. The important one for this case is the nr variable. We only need to add it to the output, and awk will print out the current record number. These examples only scratch the surface of what awk can do, but it should give you a good foundation for future learning. I frequently use awk and shell scripts to extract information from file names in large data sets. This allows me to use patterns in file names to automatically process hundreds of files in a fraction of the time that would be required by a manual process. While not as powerful as sed or awk, the utility tr, short for translate, is very useful. It replaces and deletes characters sent to it from standard input and writes the resulting text to standard output. While sed can do this as well, it can be overkill for many situations. Let's look at a simple example. In this case, we want to replace all the commas in our text file with a tab to change the file from a comma-separated file to a tab-separated file. We can do this with the following command. Replace the comma with a tab. Since tr only uses standard input, we need to dump the contents of the file using cat and then redirect that output to tr using a pipe. We can choose to replace more than one character at a time. For example, we can change all the lowercase letters into uppercase letters like this. Specify all the lowercase letters, and then the uppercase letters. We could also do this using something called a character set, which we will discuss in more detail in later videos. Let's look at the man page for TR for more information. If you scroll down, you will see that there is something what the man page calls sets that we can use instead of specifying characters explicitly. As you can see, there is a set for lowercase letters and a set for uppercase letters. We could use them in TR like this. While this did take more characters, in some situations this can be advantageous. Remember also that we can do the same thing with sed, but this is much simpler. Before I end this video, I want to reiterate that we have only seen a small fraction of the capabilities of these tools. One of the most powerful aspects of these tools is their ability to use regular expressions, which is a topic we will discuss in later videos. This video covers just enough information about these tools for you to get started using them on your own.